Hi, my name is Barbara, and I want to talk about this wonderful resistor assortment I got on Amazon. This is 20 resistors, 63 values, metal film, 1/8 watt, 1%. And as you can see, they come packaged in these little envelopes, each one labeled by hand. Quite a bit of manual labor to do that. But consider this is like 1,400 resistors for $15. That's an incredibly low price for 1% resistors. I mean, that's even low for 5% resistors. So where did this come from? How did the seller afford to do this? Well, a little bit of detective work, I think, shows us what they did. Let me talk a little bit about Resistor Manufacture. When you create a accurate part, there are several ways of doing it in the manufacturing process. One way to do it is to have a highly controlled process. That is, a manufacturing process which is so well monitored and controlled and known and run at a slow rate that it can produce extremely consistent results. So if you're making 1% resistors and you do it by having a excellent process, then you're likely to have this normal distribution in the -1 to +1% window. That's really a beautiful way to manufacture, but it isn't the cheapest. Another way you can do it is by having a sloppy process that produces quite a large range of values, and then just throw away the parts that don't meet your specification. And this would give you a distribution that's within the window. So you might see parts distributed like this. Another thing you can do is you can deliberately make your resistors as cheap as possible, and then selection to produce multiple grades of resistors. In this case, look at what happens if we produce, say, resistors that are really like 2% accurate, and we select them for 1%, but first we select them for 0.1%. We take the 0.1% resistors out, sell them at a very high price, and the leftovers that fall into the 1% grading, you sell as 1% resistors and label them as such. And then anything that falls outside that range is either a 5% resistor or it's just junk and you recycle it. So that's another option you can take when you're manufacturing resistors. And the third, controlled selection or trimming. The third is trimming. And in this case, you can deliberately make your resistors so that they're kind of asymmetrical with regard to the target value. And then use a trimming process, usually involving a laser, to push the values into the window in real time as you do the manufacturing. This is actually capable of producing the most accurate parts for the least cost, and it produces kind of a characteristic distribution that's asymmetrical. It's kind of smooth on one side and steep on the other because you pushed some of the parts into the window and left the other parts alone. Obviously, there's no need to do anything to these parts, but the parts that were over here, you have to push them down by means of the trimming process. So what is the result of looking at these resistors that we got for such a low price from Amazon? Well, I took a few values and looked at them here. And let's take a look at the result. So here's one of them, 330 ohms. In this case, the graph shows minus 1%, plus 1% limits, and this is the nominal value right here, exactly 330. And you can see that the values nearly all fell in the plus and minus 1% range, which they should, and we got 3 values that fell outside. So this is nothing to get upset about. This is very close to good 1% parts. Not the best, but I have no problem with it. I'm willing to put that in my resistor collection. Let's go on to the next one. Here's a 56K resistor that I tested in a similar manner, 20 resistors. And here you can see that the spread was somewhat worse. I would have to describe this as a 2% part. In other words, this is nominal, minus 1%, minus 2%, minus 3%. And it didn't actually fit even the 2% bracket very well. Honestly, I'm not sure if I want this part mixed in with my 1% parts. Well, let's go on. Okay, here's a 3K part. This came out of the box also. And look at this. This is excellent. All the parts except 2 ended up in the plus and minus 1% category. So yeah, this is a good part. I'm perfectly happy with paying 1 cent a piece for these parts by all means. Going on to the next value. Now I chose a very common part, probably the most common resistor, 10K. And look what we got here. This part is a complete failure. The plus and minus 1% window is violated on the downside all the way down here to minus 2, 3, 4, 5% low for quite a few of these parts. So this is basically a 5% resistor. Now they are marked 1%. You can see the markings here. Brown, red, black, black, brown. The 5th band here being brown indicates 1%. So these parts were built and manufactured as 1% parts. And apparently they were mismanufactured. These are by no means 1% parts. These are failed 1% parts. They could have been 5% parts, but they are already marked as 1% parts, and they're not. So that's a problem. Here's another common value from the same box. This is the 1%, the 1K 1% resistor. And you can see that none of the values, except maybe one, fit within the 1% bracket for 1,000 ohms. All of them are down here in the 5% bracket, and that's a serious problem for a 1% part. And again, this is, it's hard to see in this photograph. Sorry about that. Brown, black, 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 brown. Sorry, is that right? Brown. It's really hard to see that, isn't it? Anyway, that's definitely 1K, 1%. That's a brown band there, even though it's not a very good photograph. And this is nowhere close to 1%. So what happened here? Again, these appear to be fallouts or dropouts. Both terms are applicable in this case. The resistors failed their 1% selection and were probably turned loose onto the surplus market, where this vendor bought them up as being very cheap parts and put them in this assortment. So just as a sanity check, let's go back, pick another random value from the box. 680K. This one is kind of odd because here the values are all a little bit high, and they're actually fairly close to 1% for a lot of them. These are 1% parts. These are about 2% high. These are about 3% high. I think most hobbyists would be able to use this as a 1% resistor, but again, this is not really a 1% part. These are just no good for 1% parts. Perfectly good. These are not junk parts, though. They are 5% parts, and 5% parts at 1 cent a piece are worth it. Okay, here I took some parts that I already had in my box, 2K, and these are resistors that I bought from an American distributor at quite a higher cost than 1 cent a piece. And you can see how they group. These are all grouped in the lower 1% of the plus or minus 1% window. And I would have to guess that these were selected or trimmed parts. They could have been trimmed. It's more likely they were selected. If they were trimmed, we would see a larger grouping of them right in this region here, probably. That would be my guess. But they are 1% parts. These are perfectly good parts. Anyone would be happy to have these and pay 10 cents a piece for them if they had to. So what do we really have here? The parts are a problem as 1% parts. They're not 1% parts. And the question then becomes, well, what do you do? What do I do with them? I don't really want to mix some of these parts in with my expensive 1% parts. I can keep them separate. I can make a new box that is labeled 5%. But to start with, let's rate these. I'm going to have to take off 1 star, maybe 1.5 stars, for being dishonest and basically saying these are 1% parts. These are not 1% parts. These are 5% parts that are marked as 1% parts. Then perhaps take off another star for them being basically pretty mediocre parts in general. So it's minus 2.5 stars, rounding up to minus 3 stars. I guess that's a 2-star product. As long as they're labeling these as 1% resistors, you have to give this product 2 stars. Now, if the seller described them as 5% parts, then I'd give them 4 stars. Because these really are 5% parts. They're an amazing bargain. They're not junk. They're totally usable. And if you label them as 5%, then they're good. So suppose you want to mix these in with your 1% parts. Look what I did here. I took some silver nail polish and put a small bead right along the side of these 10K resistors here. So if I actually wanted to include these with my 1% parts, I could do that and just mark them as being obviously something different from my other parts. This is pretty easy to do. Here's the 1% 1K parts, which also, as we recall, were defective. And I take a random piece of paper and lay it along the parts like this. And put a bead along the parts. You don't want to get any paint on the wire itself, just the resistor itself. And you don't want to put too much, but just a little dot. There we go. So these 1K, supposedly 1% resistors are now, they have their 1% band obliterated, and we know with the little dot on them that they are something else. So maybe it's worth keeping these. I think personally I'm going to throw them away, but just for purpose of illustration, you can see what to do with them there. Now, one more thing I wanted to talk about is putting these resistors away, safe ways of doing that. Now, I don't like having the sticky adhesive on the ends of the resistors like this. So one thing you can do is get some 3M silicone tape. This is type 70, 3M type 70 tape. It's silicone. It's called fusible silicone. And take a little bit of this. Let's see. It's a little tricky to work with, but this is great stuff. I recommend that you always have a little bit handy because you can do so much with it. Any kind of high temperature, high voltage insulation that you need to do. It's great for making high voltage transformers, etc. Anyway, what you can do in this case is simply take it and fold it over the resistors like this, squeeze, and now the resistors are massed together, and you can remove the tape however you want to remove the tape. Let's see. I'm looking for my sheet metal shears. Here they are. Okay, so let's remove the tape the hard way by cutting it off with sheet metal shears. Don't do this with your light metal cutting shears because you'll probably wear them out pretty quickly. But a decent $50 set of sheet metal shears does the job just fine. Okay, so there's my handily packaged 3K resistors. And $3K, 1%, ready to drop in my box. So anyway, that's it for today. In general, these are not 1% resistors, but they are not junk resistors either. So if you actually check them and label them properly and make sure you don't mix them in with your 1% resistors, unless the value actually is 1%, then you're in good shape. So that's it for today. See you next time.